So I don't know how Jed gets out of doing an intro when he organised all of this, but I'd like to welcome Zhamak Dehghani to Atlassian today. I know Zhamak from a previous life where we worked on embedded software together, which was a really good experience. And these days she's a principal consultant with ThoughtWorks, and she's here to tell us about real-world microservices. So hopefully we can learn what not to do wrong as we start moving more and more into this space.
Cool.
Thanks, Zhamak.
Thanks, Ravi. Cool. This is great. So we've been building systems with microservices for quite a few years, and we decided to come out and share our stories and learnings, hence the title of this slide. As I was writing the blurb for this talk, I kind of thought maybe it would be more authentic and real if I asked people that I knew who had worked on microservices to send a 2-minute video of themselves, and I can incorporate into the talk. So the core of this would be them sharing stories, I'll be sharing stories, and I will give you a little bit of more technical context around what they're talking about. But before getting to the talk, I'd like you to raise your hand if you think you work on principle. If you can think of 1 or 2 principles that really guide your work. Cool. If you have pen and paper, I would love to know about them. If you can just scribble them and give me your principle later on. I like to think the reason at ThoughtWorks we are really, kind of pushing microservices and this style of grassroots architecture is that at its core, microservices has a lot of values and principles that resonate with us. The idea of autonomous teams with responsibility, decentralized governance, collaborative and distributed coding that you won't be able to pull off without having organizational empathy. We really care about those. But only in real world, when we try to implement systems with microservices, we learn that it's bloody difficult to actually be successful at it and manage the complexities that get introduced into your environment. So we try, we get hurt, we learn, adapt and improve and repeat. And hopefully we can share some of those learnings today. First, I will try to very quickly establish some baseline definition of what microservices architecture is and what it isn't. Go through the values and benefits of this architectural style, but equally talk about the complexities that get introduced into your environment. I'll try to go really quickly because I'm guessing you've done some homework, you've already got some microservices in some shape or form, and try to get to the core of the talk, which is about the stories. So, what microservices architecture is? It is a style of service-oriented architecture. It is a super hyped one right now. We sold YOW tickets in the span of 1 week in 3 cities, and here's the amazing turnout today. But it is the first one that has come post-continuous delivery. So essentially, it really relies on a lot of the foundation that continuous delivery has put in place with continuous deployment, automated provisioning, automated tests, and so on. It is a very fine-grained service-oriented architecture where the services are built around your domain capabilities. So in the past, we've seen a lot of coarse-grained services that are built around your technical capabilities, right? The services that do caching or look after the database. Microservices really turns that around, and you build services that they're self-contained, they look after all the different technical aspects such as database and caching and so on, but they're built around your domain capabilities. Here I try to demonstrate the domain capabilities of an online retail, so recommendation, shopping cart, product catalog, fulfillment, all those capabilities apply to the services in that domain. And most importantly, each of those services can go from conception to production independently of the rest of the system. So the loose coupling is absolutely, I think, essential for microservices architecture. And then that's only possible if we use integration technologies that allow that level of loose coupling. So if you're using, language dependent, API calls and so on, you can't get that level of loose coupling. So, we talk about REST, we talk about HTTP, Richardson maturity model, that sort of stuff. So to be able to have these loosely coupled services from the deployment point of view. So what microservices architecture isn't? It's not a monolithic architecture where you build one large application. And what we see is that in a lot of companies, people have a lot of discipline around building libraries, building packages, kind of divide the systems in some logical sections. But at the end of the day, if you link them all together and run them, deploy them, and operate them as one big thing, you still got a monolithic application. It's not a layered architecture either. It's a style of architecture that we kind of see when we break down the system around the cross-cutting technical capabilities. You build a UI layer, use a certain tech stack, then you build your services layer, another tech stack, you build your database layer. And in each of those layers, you're kind of conflating all the different domain capabilities into one based on that cross-cutting technical capability. It's not a whole bunch of dumb services integrated really smartly and intelligently through your middleware or your communication layer. And this is a very common one we see at our larger clients, at enterprises, where they have some form of a 90s version of service-oriented architecture, and they've got enterprise service bus that does a whole lot of routing and message transformation, and the brain of the system actually lives in there, and you can't independently change and deploy these services. They're all coupled in that layer. And lastly, it's not a bunch of services that are integrated through the shared data. And this, again, is another style of architecture we see in the digital frontiers of these organizations, where demand of supporting different channels, such as mobile and web, has resulted in building a set of APIs, building a set of services, but when you actually look behind the scene, they're still sharing the same database, and they're still kind of coupled through the data layer. So that was quick, I promised. So that's basically what microservices architecture is, and it isn't. So hopefully I established some common understanding. But why microservices? Why are we so excited about it? The first one that I kind of love the most is the autonomy of the team. And with that autonomy and freedom, the responsibility that comes with it. So for building microservices, the way you organize yourself, you have a team that has the responsibility for building and operating a service. That team can cut through layers of abstractions. If you're in a big, large organization, get to the business product owners, really understand what it is that service is doing, and go through building it, testing it, deploying it, and also get the call when the service falls over and operating it. So be responsible for the full life cycle and the destiny of that service. Another driver for a lot of organizations picking up this service is the rapid rate of change. It's much easier to build, deploy, and experiment with a small independent service than what we see is, synchronizing 5, 6, 50 different streams of work to come together at a release date to release a large piece of software. So that kind of independent services being able to deploy and experimentation done more rapidly is another driver for this. Scale of your operations. So if you break down your domain to your problem domain in subdomains and have independent teams to work on those, you can kind of scale your operations. So companies like Netflix, they've arrived at this architecture because they had to grow really fast and respond quickly to the growth of their online services. It's not hard to imagine that if you have, fine-grained APIs, being able to compose those APIs through different applications and have, more innovative and, exciting applications. The smaller the pieces of the Lego are, the more versatile your creation is going to be. And tech diversification. If you want to absorb new technology and you've got a service that can, a small service, adopting a new technology, building that with a new tech stack, when that service only talks to other services through technology agnostic kind of integration layers, that's an easier job to do than migrating millions of lines of code to a new tech stack. So you can have a polyglot environment with different services based on different requirements and different capabilities have a different tech stack. And lastly, the lower cognitive load for a developer. So if I'm a developer looking after this particular service and it's a small code base, it's easier for me to understand that service has, has a very kind of a more intimate relationship to it than understanding millions of lines of code coupled together in the app that I built. So this is great. I fill this slide with lots of values, and we feel really fuzzy and happy right now. But there are lots of complexities that come to your environment with each of those values. So you've got autonomous teams. Those teams are made of people. People make silos and walls around themselves. So if you have to now make a decision that crosses multiple teams, you've got a communication overhead. So any communication that goes cross teams needs people who are really good at those boundary roles, cross-team collaboration. So there's a communication overhead that would come with having multiple autonomous teams. It's absolutely impossible to get the speed of change if we don't invest, greasing those execution pipelines. So if you don't invest in automated tests and your contract tests and deployment environment provisioning, it's going to get really hard with lots of moving, microservices. We've now broken down the domain in lots of, independent services. Distributed computing has its own complexities. Having a resilient system, providing consistency across distributed services, those are all complexities that come to the design of and implementation of the services. And with our, really nice fine-grained APIs, our consumers have built weird and wonderful applications that now we have to maintain. So versioning of the APIs, keep expanding, our capability before we can actually collapse and throw away older versions. Maintaining the older version of the APIs is another complexity. And finally, we got excited that we can write these services with different tech stacks, and suddenly we've got the explosion of species of technologies running around, and how do you manage the operational overhead of running different tech stacks? So the way I kind of imagine it is that each of us need to have this giant granularity slider to find that sweet spot for our environment where we can get a net positive value out of the complexities and the values that we have. And it's really different for every company. A lot of our clients kind of freaked out when we said, oh, microservices has to be just 50 lines of code or 100 lines of code, because it just doesn't make sense to them. They have really complex business processes in some cases, and it's just 50 lines of code. Microservice doesn't make sense to that environment. So you just find that sweet spot for your problem domain. Ryan is one of our colleagues in San Francisco. He works for a supply chain where the business domain is quite complex, and he has a few things to share.
Microservices in a complex business domain, it's very important to pay attention to the right level of the service granularity and the service interfaces. It's not all or nothing, a monolith or nano services with 50 lines of code. In a complex business domain, it can be a challenge to evolve towards an ideal modeling of your business capabilities, especially if you're in a greenfield environment or you're adding a lot of new capability. I've been recently working a lot in the supply chain, and there it's common to have a product design concept, a product catalog concept, planning, and these concepts, if represented as microservices, may or may not have very complex interaction patterns that make it difficult to reason and evolve a design. In fact, in the work that we've been doing recently, we've found a lot of needs to move attributes and behavior across some of these services as we discover the right modeling. This can be complicated if you have third-party packages that have their own design concerns and worldview and that are influencing or backing those services. So the discovery process has typically been slowed significantly by having a microservice architecture and having to refactor across it. One of the major things is that we don't have IDE support. In static languages, we can refactor very quickly across service interfaces. On the other hand, for microservices, we're in the dark ages, doing most of that work by hand. In fact, we're maintaining additional things like contract tests, which wouldn't have been present in a monolith or in a macro service. Multiple teams also can become silos to doing the right thing. Communication is significantly higher if multiple teams are managing the different services. And possibly negotiation becomes an issue. More people owning more ideas means more overhead. You never know less than you know right now. So splitting too soon can make things very difficult to reason about, and it will likely happen that you will learn in the process. Be cautious. Monoliths mean you have domain expertise, and in those cases, splitting is often easier to understand. Rich domains and doing evolutionary architecture, on the other hand, are difficult in a microservice environment, and you should be cautious about the level of granularity that you move to as you're learning.
Ryan talked about a few things there, but one of the, I guess, subjects that I would continue on is the domain modeling. How do you actually find the seams in your system? If you're in a brownfield environment where you already have a monolith or a layered architecture and you want to break out services, how do you do that versus you're in a greenfield environment, you're really experimenting, understanding your user requirements, and how do you build services in that, model services in that environment? So in a brownfield, there are a bunch of heuristics that you can use. One of them is a domain-bounded context. So I referred to the example of online retail a little while ago, and you basically find the capability boundaries within your system, where those boundaries where the language changes. For instance, in a supply chain, the idea of a product is really different when means something else if you're in a style and design stage versus in a order and sales stage. So where the language and definition of the words change, that's kind of the, you can use that as to find the boundary for your bounded context and the services. The other one is the rate of change. Your system will be as fast, can change as fast as the slowest part. So if you want to experiment with one capability, push out more quickly versus a different capability that doesn't change as often, you kind of can use the rate of change as a way of splitting the services. The other one that we often talk about because we work in our kind of larger organizations and distributed teams is the team structure. So Melvin Conway observed in 1968, I think, that companies that design products, the design of the products is constrained by the line of communication, by the structure of the communication in their organization, which means basically that the systems that you build reflect your team structures and vice versa. So you can kind of use that to your benefit. If you we work in, we have teams in China or India or other places, and usually we use that kind of geographical location to allocate services to different teams. Or if you're in a part of organizations that you have closer, feedback loops, again, you may find that there is a service boundary within that part of the organization. So reflecting the organizational structure is another way of designing services. And stating the obvious, whatever hurts most, start with that one. So an example of that, I'm not sure if you have this problem here, but usually if you have a legacy system and talking to the legacy and integrating with that, or you have a third party and integrating with that hurts, put a facade service, define facade services that speaks your domain language, the way you want to work with that service in front of those to help with the integration pain. The other thing we talk about is, if you have a monolithic system, you probably already have those seams in your system. So if you run a whole bunch of static code analysis tools like, Structure 101 or a bunch of those are put up there, you will see those dependencies. This graph is a .NET code that I assessed about a couple of years ago, and it's the namespace dependency of that graph. I could not see what the heck was going on there. I had to drop it into this D3, edge bundling algorithm to actually see the seams. And I'm not even convinced that I want to now expose this tight coupling up to my infrastructure and processes and services. So if you have a monolithic and you feel that there are patterns that you can see to pull out capabilities, just be cautious about the coupling of those capabilities already within your system. And I guess worse than that is that when we build these systems, we condition our consumers and customers and business to work according to this system. So probably our processes and our journeys have a lot of tight feedback loops and dependencies now that you want to get right first before start pulling these things out. So how about greenfield? what sort of tools can we use if we are just experimenting with a new product or a new idea? How do we find service boundaries there? So one of the tools I have been using, sorry, this diagram is not meant to be readable because it's actually from a client of ours, so it's just to get an idea of what it looks like. It's a user journey. So it's a journey of the user through the system, and I use that as a way of finding out the capabilities in the domain that sits behind those journeys. So get your product owners, whoever are the domain experts, go through the journeys, and I usually start up with really just the post-it note exercise of writing nouns and verbs and different concepts and then grouping them into kind of bounded context and services, and to have a little bit of fun, then I play with Neo4j graph database. So it's very easy to just put this information, so your entities and your bounded context into a graph database and start writing cipher queries to see what the dependencies are, what the couplings are between the services. So it's just for me to have fun. And it's great, right? So here, this is actually a real example from another client of ours, and it was a greenfield project. It was an kind of a concept that wasn't proven before. We didn't even know if this is going to work out. And new experiment, should we go ahead and build 50 different services for this project? Probably not. We did, in fact, go and build 20 different services, and it did hurt a lot. So yeah, start one service at a time, go slow. Doesn't matter with a monolith, just if one service doesn't hurt, build 2, and then build 3, and so on. And really, what excites me is that we do have a lot of good, software engineering principles and design principles that we apply to our code. That applies to your services. Service should do one thing and one thing really well. The things that change together should stay together. I sometimes try to really convince myself that I am seeing some fractal beauty. The same principles I apply to the code, now I'm applying to the infrastructure, to processes, and to the services. So let's go back to the basics when we design services. Evan worked at REA for many years, and they have built kind of a microservices architecture working towards. So he's got a few things to share about the ownership.
So shared services are one of the hardest things to deal with, things where you've got an application or a service that actually needs occasionally to be changed by multiple teams to deliver new functionality. And where we're evolving to is that the teams will be long-lived, and they'll be structured around supporting or providing custodianship for a set of services or business processes and people. But you need to reserve some capacity for people to take their badge and their gun and go out into the organisation to enable the rest of the organisation to make changes to those shared services in a safe way, in a sustainable way, without basically reducing the overall quality of the service.
So Evan talked about long-lived teams. I'm not sure if you have this problem or not, but what I've seen in a lot of organizations is that we spin up project teams. The project teams work on a project, they form, and then the project is done, they collapse. The team collapses, and the project goes into some form of a maintenance, goes to a maintenance team to get looked after. So with microservices, we really want long-lived teams that look after one or multiple services. But with that, you may have shared services or shared capabilities, and how do you manage that in a way that there is a custodianship, ownership, but it doesn't stop from other people to come and make changes. So at REA, I think the core engineering team, for instance, is a long-lived team. I think Evan was the only actually persistent member of that team, and they had a fluid team membership, so people coming to the team and leaving the team, and so on. They also, for collaborative coding, sorry, they don't use Stash, they use Git Enterprise, and that's their model of allowing other people come and change the services with a custodian of that service, receiving the pull request and going through the whole pull request workflow of people coming, forking, making changes, and then, collaborating, commenting, reviewing, and pushing the change back to the service with the review of the custodian of the service, which is more of an open source model of code sharing. So I did mention, complexity around the execution, around testing, around building services. And Kent worked on a microservices project, which had a lot of war stories and battles to get off the ground, because we had a really large team, very short cycle to get the product out, and we decided to go crazy with microservices from day zero. So he has a few things.
So with microservices, one of the advantages is that you can quickly make small changes to services and get them out into production. And so one of the ways that you come at this is writing contract tests for each of the services. On my last project, we initially started off writing our contract tests, and we wrote them in the language of the client, but they were really much more provider contract tests, in the sense that you would add a new feature to the service and then you would change the contract test that was associated with that. But then we realized that that didn't actually allow us to deploy these to live with confidence, because it didn't necessarily matter that the service agreed with itself. It mattered that other dependent services, were getting what they needed out of that. So then we started to evolve towards consumer-driven contract tests, but then that created a lot of complexity in our CI environment, because you start to raise questions like, well, if you have two different teams working on services and the consumer service changes, needs something different out of its dependent service, is it allowed to check in a broken contract test that then fails the dependent service? And if so, now you've got coupling between your services and your CI pipelines.
And he could go on and on and on and on. We just had to cut him off. So he talked about this testing of the services and consumer-driven contracts. Do you do consumer-driven contracts here for your services sometimes? Yeah, cool. I think we all agree that integration hurts, put it lightly. The scenario that we often see is that the consumer developer, someone who consumes a service, is upset. I see this every day at stand-ups, that his tests are flaky because the service he's using goes up and down. It doesn't do what he expects. So basically, there's always mismatch expectation of the service provider not understanding what the consumer really wants, and the consumer not knowing how the service is supposed to behave, and misunderstanding. So the naive kind of solution to that is for the consumer to go ahead and write a whole bunch of mocks and stops for the service based on his probably misunderstood assumptions, and the provider go and beef up his API test and contract test based on his own assumptions of how the consumer is supposed to use the service. So with consumer-driven contracts, we kind of flip this, right? We try to expose those misunderstandings quite early on with the provider providing the mocks or stops, and with this consumer writing the contracts for the service provider to implement. So, and at realestate.com.au, I think they've got a Ruby library of Pact, which allows the consumer developers, at the time they write the consumer code, they write the expectations or the packed files from the service provider pipeline consume that as an artifact dependency and runs that on its own pipeline. And as they develop the services, the tests go green. So that's kind of the general idea. And how this is going to help us with microservices. So this is a very simplified kind of visualization of what the build pipelines usually look like. You've got a whole bunch of independent pipelines that they can go so far, right? For each service, you can build it, you can unit test it, component test it, but then you get a point that you push the services together in an integration environment where you run your end-to-end integration tests and acceptance tests, and quite a heavy reliance on integration testing before you can say, I can release this to production. this is going to be really hard with lots of moving parts, with lots of services. So I'm going to do some magic. Here's the magic of the consumer-driven contracts. So what it means, what I try to show is that those little colored boxes within the services pipeline are the consumer contracts that each pipeline consumes. So as a service provider, I can consume all my consumer contracts, and I can push that change all the way to production, and knowing that I haven't upset any of my consumers' assumptions and expectations. Kent talked about an idea that we don't know how to get it right yet, but I find it very intriguing. The idea of the self-healing networks and self-healing pipelines. He talked about, what if, as a consumer, the way I communicate to my provider, my expectation or my change of expectation is by changing my consumer contract and breaking your build. And you respond quickly and change the service in response to that, and the network heals itself, the pipeline heals itself. We haven't been successful with that yet, but I think it's a great idea. But you need a maturity and a rapid response to change, and probably a little bit of conversation before doing that. But it's intriguing. Self-healing pipelines. You need a bit of empathy, though, I think, as well. It's just saying. Right. So, yep, we build the services. They've gone to production. What can we do about monitoring?
A project that was successful. One of the teams wrote down a set of proposed standard health check endpoints, a set of URLs that would expose information about a service. And they shared a library that would make it easy to publish those service endpoints or health check endpoints out of an application. And because they made it simple, that very quickly became a standard across our organisation. Very simple to use as a human using a web browser or a command line, but also easy to hook up to our monitoring. So these service URLs would expose the application version, the current health check, heartbeats for load balancers, as well as more detailed diagnostics. So I think that the lesson I took from that team was keep it very simple, keep it plain text, make it accessible to humans, and make it a simple standard without being laborious.
I think he just stated the obvious, but I asked him to actually give me the curl output of some of those endpoints. This one is hitting the public API of realestate.com.au, but for each of the services, they have exactly the same endpoints as they bring in the same library into the service. So this one is for the load balancer. You're just getting the HTTP response code. And the next one, I think they were using Nagios at the time, and for their monitoring, so they had another endpoint that was giving the response with a little bit of a text for the Nagios to use to report the overall health of the system. And the last one is for human readable response, if we can actually read down there. So it's just a HTML output of the status of the system. So we've got a whole bunch of, we talked about the endpoints, you can do monitoring, but the shape of the monitoring changes with microservices. You go from monitoring one thing to monitoring, a network of services. So being able to do aggregated monitoring is quite important. Being able to get metrics out of each service, but be able to aggregate it, filter it, still visualize it. And there is a whole ecosystem of tools to use. I just put Graphite here as an example of log aggregators to see the logs and graphing on top of it for visualization. Another one that I actually played with last month, I've come across, is Rimon. Have you played with Rimon here? Yeah. It's really neat. So it's actually just an event processor. It doesn't store your events or anything, but you can put these Rimon nodes or Rimon processes across your network, your clusters, however you deployed it, and get events from any source or any service. Events are just, hash map of time-stamped information, I suppose. And with Riemann, you can write closure scripts and as expressions to do filtering, roll-up events, and then send notifications to Graphite or your alerts or your email system. And what I liked about it is that a lot of the other systems that we see, you have to write some, funky DSL that can take you so far. But with Riemann, you can actually write closure code, which is quite neat and quite flexible. And you can chain them up in a hierarchy as well and aggregate kind of Riemann events. And why just do passive monitoring? That we kind of listen for things to fall over and notice. We can do kind of active monitoring by running synthetic transactions. So one of the things that we try to do is when we build kind of our journey test or end-to-end test, which is only a very small set of tests that go through the whole application, we actually package those and publish those as part of our production deployment, and we just run them through production to catch those nasty bugs early. On an online retail, though, you need to be careful that you don't end up buying your own products, frequently with your test. So, yeah, more on operational complexity and trade-offs from Kent.
In software, there's certainly good practices and bad practices, but typically the more interesting questions are around trade-offs. Do I do something now, or do I do it later? Am I optimizing for X, or am I optimizing for Y? Microservices are certainly no different in this regard. On the one hand, they allow quick deployments of small changes to production. On the other hand, you now have a much more complicated CI pipeline that you have to look after. Similarly, microservices are small and easy to reason about as a developer, but now my environments are complex and much harder to reason about as a developer. So thinking about these trade-offs with microservices, I think they're particularly interesting when it comes to greenfield projects. Historically, microservices have been more around decomposing monoliths, teams that have built up a lot of code and experience and are unable to sort of ship as quickly and easily as they want. So they start decomposing these bits one at a time in a controlled manner. But now that microservices have become popular, it's more common for people to start with them. We had this on my last project. It was a greenfield project, and we chose microservices because we needed to get up fast. We saw the appeal of having bounded context. Each team could own its microservice and its pipeline, deliver that. On the other hand, it required a number of us to sort of run around frantically at the beginning, once again making these trade-offs. Where do you cut corners in terms of all of the ceremony that's required on microservices? CI pipelines, no, can't cut corners there. Server standards, practices, shared code, service templates. It turns out there's a number of these things. So once again, you come to this consideration of, what are the trade-offs that I'm willing to take? And for instance, one of the things that we decided to defer was having a, sort of a real logging approach to logging, in terms of having correlation IDs that went through all of the various services and having a sort of a robust set of automatic logging. And in the end, that was something that turned out to bite us. So, if I were to go back and do that again, I would put logging sort of much closer to the front. What would I pull out? Not entirely sure. But, greenfield microservices, I'd say be really careful with those trade-offs.
It was interesting to see Kent talking about kind of trade-offs and greenfield microservices, similarly to Ryan. They haven't even met. They work in completely different continents. So he talks about logging, structured logging, use logging as a means of monitoring, for instance. So the way I remember logging in the old days, you only look at it post-mortem. Things go wrong, and then you get the logs from your support and search through them and to figure out what went wrong. With microservices, you kind of logging is another source of monitoring in itself. And but now that your calls go through a network of services, it's important to be able to kind of correlate logs. If things go wrong, go back to the root cause of it. And being able to have the correlation IDs, which are basically hierarchical IDs that you produce as you make a call, and cascade your transaction through your services, and be able to structurally kind of log those in your logs and, get your log aggregation systems, again, open source ones, Logstash or Kibana for filtering and querying on top of it, aggregate the logs and be able to use that as another source of monitoring or find the root cause of the problems. And I've heard that Logstash Kibana does basically what tools like proprietary tools like Splunk basically do. So, so we've got logging, monitoring. Things go wrong, we can get to the root cause much more faster, much more easily. But how can we stop the problems from cascading through the system? The state of a monolithic is quite simple, right? It's binary. It's either up or down. And the classic ThoughtWorks story I've heard is an airline that was grounded when the Icelandic volcano erupted a couple of years back, and it wasn't due to the ash. Basically, they had one monolithic system for reservation as well as boarding. So the site and system went down, by death by refresh, people trying to rebook their flights, and then nobody could get on the plane. That's not good. With microservices now, we've got lots of little pieces that each of them can behave differently. They can be all up, or all down, or mostly up, or up from one, or all the most important bits up. And you've got this double-edged sword now. It's not a monolith. It doesn't have two states, but you have large number of independent pieces that can misbehave. So what do you do about that? Luckily, Michael Nygaard has written this great book. Who has read or has released it? Yeah, perfect. It's a pretty good book, and it has a lot of, a dozen different fault tolerance patterns that you can build. And Circuit Breaker is just one of them, is the one that I guess I liked most and I understood most easily out of all. And it's the concept of that comes from, electronic circuits, where if you have a component on your circuit that's misbehaving, you kind of break that apart and separate it so it doesn't burn everything down. And this actually, I found a lot of use from it, and this is a true story. It happens in my house every Saturday when I cook breakfast. I make coffee and toast bread and boiled water for my poached egg all at the same time on the same power board, and the circuit breaker opens. Otherwise, I would have burned my house down a few times already. And the way it works is that your circuit is closed, so the request that you make to the services, downstream services, goes through. As soon as the request starts failing, you probably have a threshold of failures in a rolling window that you would hit, and then the circuit opens. No call goes through. You probably have some timeout before you can recover, go into a half-open state. In a half-open state, the next call coming in, if it goes through successful, you go close the state. If it fails, you go back to open. And if you've looked at Netflix Hystrix library, they've kind of modeled this around the Java command pattern, where all of your requests are wrapped with a circuit breaker object, and that looks after this state machine in a way. And you can also have failover options as, okay, I'm in this open mode, what shall I do with my request? Should I return nothing? Should I hit the memcache? Should I return canned data? You can choose as you wish. The neat thing about Hystrix is that it actually exposes metrics out of the library itself to their dashboard, and in their dashboard you can see the state of the circuit for each of those services, whether it's open or not. Building monitoring is just the beginning, right? The services change and evolve, so what can we do about maintainability?
So I've been thinking about the projects that I've done recently and over the years, and I think consistently, one of the most painful things is when you have to integrate with another service, especially ones that are built inside your own organization. Primarily, that's painful because of this integration dance that you have to go through, that you send some emails, you organize some meetings, you get some out-of-date Word documents, maybe you get access to a test server that you can poke around in, but overall the whole process is very ad hoc and kind of painful. And next time you integrate with a different service, it's a whole different dance, and that's just really painful and really crap. And it just doesn't scale, is what I found. When we work on these architectures that have more and more services involved with them, we can't be investing the time to manually discover how each one works. So the big kind of revelation that I had was that these people that built HTTP and hypermedia, they actually kind of know what they're talking about, and we should probably listen to them. So I've had some very successful architectures recently where we've done true hypermedia with links and programmatic navigation of APIs. We've had situations where we can refactor services, deprecate services, and introduce new ones without consumers of them ever really knowing that it's happening. They continue to navigate links, the links point to a new location, or they redirect if they need to be permanent, and things carry on. You know, we can change the shape of our infrastructure and our systems without the consumers really knowing. And that has been the real big takeaway for me, that consistency externally is incredibly useful. It can really help you with ramp-up times, and it can really help you with everything, really, with testing, with integration, with discoverability. It's all just so much easier when the services themselves are self-discoverable.
Right. So, yeah, James talked about services self-discoverability and kind of disconnected services. We know that we would probably get the boundary of services wrong. We probably get the structure of the API wrong, and we want to be able to change that without upsetting the consumer. So I asked him to send me an example of what he was actually working on. He was working on a tracking service that would track your orders and give the status of your tracking orders. So how do you discover the APIs that you need to call as a consumer? The options HTTP request is just for the purpose of documentation. Let's say we have arrived at the root of our tracking service. We have those options available to us, and it says it's order status API route for all things order tracking related. Great. We do a get on the route, and from there, we are interested to know about the orders. So we follow the URL of the orders member, and we arrive here. We do a get on the orders, which we didn't know where it was, right? We're just following our nose and following the hrefs in the request. And we are interested in the status of a particular order, and we have a templated URL for that, which we will follow to see the status of the particular order, in which case order 1. So we do a get on orders 1, and here we go. We've got the status in delivery in progress and status out for delivery. So if I now change, where the orders come from or the URL that it comes from, my consumer doesn't get affected by it because they just follow the URLs that I expose to them. And this is, explained as, I don't know, you guys probably already familiar with the HTS maturity model level 3 or Richardson maturity model to use HTTP and to use HTTP URLs and discoverability to kind of loosely couple your services and consumers. Right, so we're going to shift gear a little bit and start talking about philosophy with Scott.
Number of microservices implementations go awry because they fail to think about this problem of modeling the business as a sequence of domain events. So actually understanding what are the business events that occur in your domain, and then making a provision for storing them over the long term and exposing them in feeds to other services. This is something that it's helpful if you plan for that up front. It's very difficult to retrofit that kind of capability into a system once you've already built it.
History is the version of past events that people have decided to agree upon. It's a very different way of looking at the world, at least for me. So the way I always construct the model of the world around me or the product is through states and state machines. I care about the states a lot. So, I'm in one state, I receive a whole bunch of events, and then I change my state and go into another state. And we keep track of the states. I have an account, I receive a debit request, and now my account goes from $100 to $50. I keep that state. I get a deposit event, I go to, back to $100. So I keep the states. What Scott is talking about is actually flipping that and put the emphasis on the events and arriving at the state by replaying and applying whatever function you want to those events to project the state that you care about. So to put this in the context of, I guess, domain modeling, what I see often is that we're very comfortable with entity-centric services, right? This may not apply necessarily to your domain, but I've seen a customer service everywhere, customer service or credit service. These are very entity-centric kind of services. We get a little bit more sophisticated, and we have this activity and functional kind of services where they apply a function on a couple of different services. To purchase, I need to know something about the customer and the credit that the customer has to get the purchase to go through. But then we find these funny little features that they don't fit in this whole nice bounded context world where you have a nice kind of bounded context and a model around either entities or functions. They kind of need to know about everything. So they're very aggregator-centric. Notification boards, leaderboards. I need to know all the events or all the news that has happened. I need to search everywhere. I need to give reports everywhere. And usually we discover these features late in the process as well. And the typical implementation is run an ETL job. Just go through the database for all of those services, get the data out, and process it as you want. And now we've just kind of broken down that nice abstraction, and we've exposed the internal domain of those services. So the alternative for that is, instead of exposing the state from those entities, exposing the events that happen through your system. Timed occurrences of things, the customer register, the credit debited, and publish those events whether through your RESTful endpoint or through other ways of publish the subscriber models, and let the consumers to replay those events and arrive and extract project the state that they care about, not the state that you care about as a provider of those events. And what we found is actually quite cool is where we had to build like gamification into a product, where we actually didn't know what the rules of the game need to be, how we need to change the behavior of the system until the people had played and interacted with the system. So having all the interactions of the user with the system as a series of events and being able to replay them being quite useful. A few honest feelings shared by JR.
I would like to talk about one thing that I'm glad we did and one thing that I regret we didn't do to ensure low coupling between the services in my last microservice project. The thing that I'm glad we did is really consider aggregating data in the client itself, as opposed to creating a new microservice or a new endpoint for that. So, for instance, what we had is that we had a screen where we wanted to display general customer information alongside financial information related to the customer. And what we decided to do is to make several services calls in the client and not create a new endpoint. I like this idea because the client is naturally a good place to I think do aggregation and orchestration. This is at the end of the day what it is, to provide a compelling user experience. And the other thing is that when you actually implement that in the client, you're closer to the client. So you got a better informed a context for knowing whether you need to make a synchronous call, an asynchronous call, and how it's going to impact the end user. So really, I'm glad we did consider using the client as opposed to a new microservice. The second thing that I regret we didn't do is really enabling asynchronous communications using something like an event stream, which could be implemented using maybe some kind of enterprise queuing system, or an Atom on RSS feed, or maybe rolling out our own. So basically, what we ended up having is a complex workflows that involve synchronous and asynchronous calls, usually being implemented in one service, which creating a very high coupling and making those services more difficult to maintain. So really, if you know you're going to have complex workflows, I would really consider rolling out early some kind of event stream.
Okay, so we talked about event streams, I think, already in the, as Scott mentioned. I think one of the things that resonates with me most from JR is leaving the composition to the layer of your architecture, or the application that has the most context, which is basically the client application. And what that means is that you don't build services that try to encapsulate your workflows or orchestration of other calls, and you end up having much more fine-grained APIs and fine-grained services that you kind of compose in the UI, who has the context. In terms of synchronous and asynchronous calls, so yeah, mixing. I think the scenario JR had, they as part of registration of a new customer, they had a couple of synchronous calls to create the customer record, but then they had to go off and send a request and forget to send email or create a record in their the accounting system. And I guess if you want to do that sort of workflows, reactive programming is a nice way of handling that, to scatter your calls and then get notification when the response has been gathered, whether it's been failed. And I'm not going to even pretend we can cover anything on reactive programming, but there are libraries. If you're doing it in the JavaScript world, you've got the promises libraries, and in the Java world, I guess an implementation of that is from Netflix as well. Ending on a much happier note from Giles.
Interesting about microservice architectures is the flexibility that they give you. And it's the flexibility that you don't even expect you're going to need that's really valuable. Late last year, we were building a sports broadcasting application that was going to cover a 3-week-long tournament of a fairly popular sport. We did some research, we found out how many users to expect. And then when the tournament started, we discovered in the first hour that we were actually getting 100 times more users than we expected. For the first 2 days, our servers melted. Then on the third day, the tournament had a break, we had a rest and a chance to do what we could to fix it. And this was where the flexibility of the microservice architecture came in. Because the systems that backed our mobile application were all independent, were small, were easy to understand, and responded predictably to change, we could look across these services and understand where caching differed, where freshness requirements were different. And what we found we were able to do was drop a CDN, content distribution network, between our mobile application and many of our back-end services. And from there, of course, we've made scaling performance someone else's problem, which is really what you want it to be. Over the rest of the tournament, users and viewers continued to increase, and we ended up doubling. Throughout that period, our system did not blink, just happily soaked up the load. And ultimately, this is really interesting in that it wasn't even this kind of flexibility that we expected. What we expected was to be able to add new features as the tournament progressed. The idea was to start off with an application that you could use to watch the tournament, and then we'd enhance it with features that showed you more detail and more insight into what was going on. But we found that using the same architecture and the same approach, we were very easily able to incorporate fairly large-scale architectural changes really simply into the system to deliver the performance we needed. I've since been told that this architecture really needs to be written up and stapled to anyone who doesn't think that flexibility in links and disconnected systems are a valuable thing to build.
So that fairly popular sport was the game of chess. The system that we're building was supposed to work on iPads, and you could pay a small fee to join, see the game, comment, enrich the experience. What they learned was nobody actually wanted to pay to watch the game. So they went online on the web for free, and what they learned was that people loved for free watching and commenting on chess. So they went from like requirement for 120 users with 6,000 users concurrently, simultaneous users. And the technical solution that really Giles is talking about is the same point that James was talking about. Having the flexibility of the links and the decoupling of the services so you can move them around without kind of rewriting the whole application. I think they were hosting on Heroku and they reached the maximum number of diners and they couldn't do, and that's where the kind of caching came to help with that. And they spend about $4.5 thousand and kind of saved the day. So leave you with a few takeaways. Know your problem domain and make sure microservices is actually the right architecture for you. It's solving the problems that you have. And if it is, really understand your domain capabilities, because there is a very close mirroring of the services and the capabilities that you want to offer with your systems. Get one of those giant granularity sliders and really trade off the complexities and the benefits that you get. It's not just an architectural, model. It is also an organizational change to build the teams in the right form, and also, the cultural shift of pushing DevOps to every single developer. You get the call, you monitor, you operate the services. Go slow. Go from macro to micro, and really build continuous delivery from day zero. I don't know if there is such a thing as day zero, but if you're building a service, the first thing you probably want to build is your build pipeline that pushes your Hello World service from code submission to production. The second thing that you build is your consumer contracts, and the third thing that you build is the service itself. We got hurt really badly, I think, on a few projects when we underestimated the amount of operations work and engineering needed to go to really grease those build pipelines. And make sure you're tall enough. So Martin Fowler has a new blog post, if you haven't seen it, which he talks about the requirements of microservices, because this ride is going to hurt if you're not tall enough. But he talks about basically the continuous delivery practices that you need to invest in. A few books. So the left one is Building Microservices is new from Sam Neiman. It's on O'Reilly, I think an early release of it, but it will come out by the end of the year. I personally quite like Implementing Domain-Driven Design. It's a very kind of practical book, because I find Eric Evans' book, I probably didn't read the second half properly, but that one goes from, how in an agile kind of world you go from design and modeling all the way to building CQRS or event sourcing or different models of the services. And the rest of them are really classics. You should already have them. So that's it. Thank you.
Time for questions?
Sure.
Hi, I didn't hear about transactions. When we talk about microservices, I think one of the biggest things is talking about the transactions. So I would love if you can talk about it.
Sure, don't have them. Cross services. So so it's, I don't know, we take them for granted when we build monolithic services. You get a call, you open the transaction, do a whole bunch of stuff, close it, and that's like how we build applications. With microservices, I guess, if you have to do transactions, cross services, the first thing I would do is really evaluate, do I really need this transaction? The second thing I would do is probably put those services, if I definitely need to have those transactions, I'll put the services together. Then if that doesn't work, the third thing I would do is I would have some form of an eventual consistency with events, use event sourcing as a way of propagating duplicate states essentially across multiple services. So that's kind of a general guideline, I suppose, without going through the details of CAP theorem and so on.
So it looks like the microservices model seems to be mostly to do with web-related technology. What about like sort of desktop applications, like or sort of you ship an application to a customer? How would you turn that into a microservices architecture, or how would you have a mix of both where you need to ship a monolithic app to a customer, but then that monolithic app might require microservices, and how would you ship those to the customer when you don't actually own the infrastructure that they are going to run your product on?
Sure. I think even if you're building, fine-grained architectures would apply whether you're building a desktop application or not, because it's not just about the end delivery product, but it's the process that you go through to build that product. When I think retrospectively, actually, about the application that Robbie and I were working on in our past job, right? We had this monolithic application. It can be broken down into really neat independent services, but we did start with having, we had a desktop application. It was calling a set of APIs on a big server that was doing some really independent capability, part of work. So having that in one monolith, what it made for us was that our QA phase was massive, because you didn't know what you impacted and what you changing a single line of that code. So I would say architectures, fine-grained architectures like microservices will bring down your fixed overhead of producing software. And by fixed overhead, I would say go and look at the cost of building software. Even if you change a single line of code, what is the cost of pushing that change to a release, right? If you broke that monolith into kind of independent pieces of software that talk to each other in loosely coupled, and you were in a world that you could change that piece and incorporate it into a release with confidence that you haven't broken down the rest of ecosystem, that is still valuable. Yes, you do need, communication ways, like we used Corba at the time, and it's really tightly coupling the endpoints, and you need to get that independence, then you need your comms to allow that decoupling. But I would like to think that it still applies.
It's actually two questions here. First one is, we're dealing with this huge, terribly coupled monolithic app, and there's two schools of thoughts here. One is that we should first go for unified deployment, like keep it all deployed at the same and then functionally decompose it, and then perhaps think about moving to a microservice model, so you're not changing too many things at once. The other alternative is that you won't do that functional decomposition properly unless you bite the bullet and actually move out to a microservice to start with. What's your experience with that?
Very good question. I would definitely say that external consistency, and by external consistency, I mean how you build, how you deploy, how even you run, your services, whether it's one service is one monolith or multiple services, is absolutely something you want to get at, right? So even if you want to you're building a monolith, you want to build, test, deploy the same way that you had independent services. So investing in your execution pipeline is absolutely a prerequisite for building a single service. So I don't think you can get away from doing that anyway. I think the question you're asking is whether we should invest that on the monolith that we have right now, or whether we should start building one service and do that investment on the service. Is that a good correct
sort
summary,
of? It's
or?
like we can invest in the pipeline, and the pipeline's not too bad. It's just that the monolith is pretty terrible. Do you tackle both the independent deployment and the functional decomposition at once, or do you do them serially?
I don't know. I would actually go back to you and say, given your constraints of your environment, what makes sense to you? Because it's not just from the architectural point of view, it's from your organizational point of view, your teams doing this work. There's so many other factors to make that decision. Yeah. Sorry, don't have a silver bullet answer.
You talked about the benefits that you get from microservices as far as independent development and independent deployment of the different services. Surely that will mean at various points in time you will have different services that are written against different versions of interfaces, and you mentioned interface versioning. Would you be willing to elaborate on some of the successful techniques you have come across for that microservice API versioning?
Sure, absolutely. So I had this heated argument once with a colleague. I was going, we have to put the version number in the API. How can you not do that? And he was just really angry at me that I would even think of that. It took me a while to figure out what he actually meant. What he meant was we usually use versioning as a way of just bumping it and changing it and having this volatile environment for our consumers. So his model was that you don't need versioning because you keep expanding and you keep supporting your existing consumer base. But that was just, that was crazy talk, like the other end of the spectrum. So I think my position would be, yes, we do need versioning, but I personally wouldn't put it in my API URL and having it bumped all the time. I'll probably have, a header that my client can tell me what version it can accept, and then I would accordingly respect that. But I would probably use versioning as a last resort for incrementing a major, version number as really a last resort and keep expanding. And then even if you introduce major version, non-backward compatible versions, you still keep the previous ones to slowly bring your clients along. I don't know if I answered your question.
So you would endorse the possibility of including versioning in the payload of an API rather than in the URL?
That's my personal I can't represent ThoughtWorks in this. It's just my personal thing. And the reason for me is that I'm a big fan of the URL discoverability. And let's say if I have a service that actually points, it's an aggregator service, so it gives you a list of bunch of different things that those resources are actually in another service. So if I put the URL version in the URL of those downstream services I'm aggregating, which version I'm putting in there? It's the version I understand. It's not the version that my client understands. So I want to leave that to the final consumer to say what version of those resources they can consume.
So going back, you had a couple of points about URL discovery and sort of using the hypertext methods to go through and find different resources. In the situation where your client is a long way from your server, so a high latency link, you run into a problem there where, if you go to a first page, then you got to get the next link, then you got to come back and forth. I think in your example, you had 4 or 5 different links going through. You're at, from here to the US, you're almost at a second to get a single response.
Yep.
The obvious answer to that would be some kind of aggregator that runs on the server side, but that seems to be in contradiction to what you said later, to try and avoid doing the aggregation on the server side, but try and push it onto the client side. Have you run into these situations before, and what methods have you used to get around them?
Yeah, so if you actually look at those URLs that came from James, there are a bunch of cache headers that he's put in there, max age and expiry and so on. And the usual argument that we make in terms of optimization of that is that by setting those cache headers, a lot of those, especially the root calls, the aggregator calls, become a no-op hitting your local cache. So that would be the first option. And if you need, then further optimization would be the aggregators.
Excuse me. So in the trade-offs slide that you had, there's sort of a lot of kind of flowery benefits about your faster, greater flexibility, things like this. How have you managed to articulate those in a more sort of quantitative way so that you can get an organization that's sort of heavily invested in doing it a different way to to kind of go, oh, I know how much I should invest in doing it in a different way?
I'm sure there's a mathematical function there to apply. I haven't come up with one. I don't know. So the actual function that you can apply to say what is the, where, like, even if you think about the cognitive load, right? As your services, if this is a graph of the scale of my granularity, as the services get smaller, my cognitive load gets smaller and smaller. But there would be a point in time that there is so much context that is pushed to the whole ecosystem that to understand what the heck is going on, now your cognitive load goes up, right? So it's hard. I think it would be I would lodge a patent if I come up with a function that actually tells me what is my net value. It's hard. So it's based on basically experimenting with services and see when it hurts and it's going slow. Very qualitative, not quantitative at this point.
Okay. One might have time for one more question.
Sorry, I am totally against microservices, so I want to be straightforward with you.
Who let you in?
I know, sorry, I will go. Basically, I want to tell you my experience. So we started with microservices. Yeah. Every microservice was correct. Leaderboards, matchmaking, user inventories, big game, right? We got to 15 microservices. It was no more microservices, it was big services. So every service needed a cache. So if I would want to run this in this laptop, the last Mac, I couldn't. I needed like a latest Xeon server, super quad core, blah, 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 to run the entire application. And at that point, it became useless because every time I needed to start a server, it was like more than 10 minutes because I needed to start 15 services. Every service had its own cache. And not only that, it was duplicating the memory because one of the services didn't want to ask to the other services again the information. I needed to cache again the information. So everybody was caching, duplicating, triplicating the memory. So it became a point that it was really frustrating to work with microservices. So I want to know from your experience, I worked with more than 250 people in that project. If you got to that large of enterprise, and if they felt like they were happy. I don't know. I wasn't.
Yeah,
sure. I'm for sure.
So we have like two opposite examples that I can give you. On a very we had a 6-month project. And we did have exactly 15 services in that project. We had no capacity to really build the infrastructure for our testing, for our, even light integrated journey testing, for infrastructure to just bring up fake services. So we built it in a way that if I was writing a service, I would just talk to a whole bunch of fake services and fake endpoints. We really had no capacity for building all the maturity in our operational and execution platform. So that did definitely hurt, and it sounds like you had the same experience. On the other hand, we have the kind of the REA example that they've gone really slow. It's taken them a few years to get where they are, and they've done a huge amount of effort into the engineering of those infrastructures, how you boot up services, how you even stencil building services. There's a huge amount of, I think, execution overheads and engineering that goes with it to be successful and not hurt. Yeah. Cool.
All right. Could everyone put their hands together for a great talk from Zhamak?